Hi ladies, this is lesson 7.1 and it's about similar polygons. So in this lesson we're going to look at, we've in the past looked at congruent polygons, but now we're going to look at similar polygons. They're a little bit different. They have some similar characteristics and some characteristics that are a little different concept. But this whole chapter is about establishing similarity between polygons, triangles, and other figures. So the first thing that we need to do before we even get into similarity is look at ratios. So this should be a review from algebra. So in these ratios, I want you to use the same units and put it in a fraction. So we're going to put it into fraction form. Improper fractions are best compared to mixed numbers so that you can see whether or not once we get into proportions, whether or not they're the same. So what I want you to do now, and just as a warm-up on your note sheets, you should see these ones. I want you to reduce these to simplest form. So you can pause this video while you work. And then unpause for the solution. So in the first one, you can reduce both the numerator and the denominator by 3, and so you can simplify that as an improper fraction to 13 to 11. The second one, you can simplify both numerator and denominator by a factor of 25, which gives you 3 to 16. In number 3, you want to get those into similar units. So 6 days for every 14 days, which is 3 days to 7 days. And then in the last one, you can either convert both to feet or both to inches. If you do inches, you get 24 inches to 36 inches, or 2 to 3 inches. Or if you convert to feet, right away, you get 2 to 3 feet. So keep the improper fraction, use the same unit. So our definitions that you have on your note sheet are similar in proportion. So this is a symbol for similar. If you see that symbol, it means similar. Two polygons are similar if and only if corresponding angles are congruent and corresponding sides are proportional. And for our definition of proportional that we're going to use in this statement, it's the statement of equality between two ratios. So for example, the ratio 6 to 18 is equivalent to the ratio 1 to 3. So those are two equal ratios. That means that those two are a proportion. So in these next two, determine whether the following are a proportion. So you can do this a couple of different ways. You can reduce into simplest form. You can divide to get a decimal or a mixed number maybe. Or you can cross multiply. So let's do this let's do number 5. And we're going to reduce each fraction or each ratio to simplest form. So 3 to 45 is equivalent to 1 to 15. And then 4 to 60 is equivalent to 1 to 15. Those are two equivalent ratios. So yes, this is a proportion. So the other way you can do it is you can cross multiply. So 3 times 60 is 180, and 45 times 4 is 180. So yes, they are proportional. And the third way you can do it is to get a decimal. So 3 divided by 45, is that equal to 4 divided by 60? Yes, those are equivalent expressions. So 0.066 repeating equals 0.06. 6, repeating. All right, so try this next one on your own. You can pause the video while you work, and then unpause the video for the solution. So in the second example, number 6, if you cross multiplied, you got 225 is equal to 210, which is not true, therefore it is not proportional. If you reduce these to simplest form fraction, 1/14 is not equal to 1/15. Not proportional. In this next section, I want you to, with a protractor and with a ruler, in degrees, measure each angle in polygon ABCDEF, and with your protractor in degrees, measure each angle of the corresponding angle in polygon PQRSTU. So ABCDEF, and the corresponding angles, which are PQRSTU. Then, after you've measured each angle and each corresponding angle, do the same with the sides. So each side, so side AB, BC, CD, DE, EF, and FA, and all the corresponding sides. So you can pause the video while you work, and unpause for the solution. Now, anytime that you're using a protractor or a ruler and you're making estimates and everything isn't perfectly degrees of 5 or centimeters of 1 or 1/2, you're going to have a little bit of variance, and that's okay. So we'll say if you're within 3 degrees on either side, we'll call it fine. But you really shouldn't be off more than 3 degrees. So if any of your angles are more than 3 degrees off here, try measuring again, especially if they're off more than 5 degrees. But here's about what you should have gotten for the angles and the corresponding angles. Now, if you notice, all of these angles, A, B, C, D, E, F, those are all congruent to their corresponding angle. A is congruent to P, B is congruent to Q, C is congruent to R, and so on. D and S, E and T, and F and angle U. Now, if you look at the sides are not congruent. And if you look at the 2 polygons, you can clearly see that polygon ABCDEF is much smaller than polygon PQRSTU. But if you compare the sides and the corresponding sides, and if we were to write this as ratios, you would notice a pattern. So I'm going to write these down all as ratios so that you can see some similarity. So 1.25 over 2.5, that's the same as 1 over 2. 1.5 over 3, again, is the same as 1 over 2. CD is 0.75 over its corresponding side. Again, if we simplify that, that's 1 over 2. DE to ST is 1 over 2. EF to TU is the same as 1 over 2. And then FA and UP are the same, 1 over 2. The proportions are equivalent, or the ratios are equivalent. So all corresponding sides are proportional. You can match them up as equivalent ratios. So when we compare those two polygons, all the angles are congruent and all the corresponding sides are proportional. So this means that polygon ABCDEF is similar to polygon PQRSTU. So now let's look at a dilated image. And a dilated image just means a stretched or a shrunken image. So we're going to look at, I have, on your note sheet, I don't think I printed the coordinates, but you should be able to determine the coordinates for each point of that original image. So I want you to choose a factor that you're going to multiply your figure by, and then I want you to plot those points on your new coordinate plane. So for an example, I'm going to choose 1/2. So choose a different factor. You can use one of the factors that are given, or you can use your own factor. But I'm going to use 1/2 just as an example, and I want you to choose something different. So I'm going to take each coordinate, the x and the y coordinate, and I'm going to multiply by 1/2. So coordinate A is -4, -4. If I multiply that by 1/2, I get -2, -2. And then I'm going to plot that point. I'm going to do that with all of my points, and I want you to do the same. So again, you can use a factor of 3/4 or a factor of 2 or 3 or whatever you'd like, but just do something different than 1/2. And you can pause while you work and unpause for the solution. Okay, so on the new coordinate plane, you can see the original image in red, and then the factor of 1/2 in black, and the factor of 2 in green. Now, what do you notice about all of those images? There might be a couple things that you see right away. So maybe you notice that all corresponding sides are parallel. Maybe you notice that all corresponding angles are congruent. And then the last thing you should notice is that it just looks like it's a stretched image. It looks like a similar image where the sides are proportional. It doesn't look like it's stretched too wide, or it doesn't look like it's stretched too long. It looks exactly proportional. So if a polygon is a dilated image of another, a shrunken or a stretched out image of another polygon, and this time we stretched it above the origin, then the polygons are similar. And then secondly, since one circle can be dilated to transform onto another circle, all circles are similar. And we can use circles to show similarity between these images. So let's start with the smallest image. So if all circles are similar, here's our first circle, and see how the points for the most part are pretty close. It's not a perfectly circumscribed circle, but it's pretty close. And then again, starting at the origin. Again, not perfectly inscribed, but very close. And then lastly, starting at the origin. And again, not perfectly inscribed, but also very close. So those are 3 similar circles, and those are 3 similar polygons. So the space between the edge of the circle or any point on the circle, and any one of those points, point A, for example, is not on it, point C is not on the circle, but the proportion between the distance of those points and the point on a circle is growing larger, or the space is growing larger as the circle grows larger. So let's look at examples of non-similar polygons. So in the first polygon, these two are not similar. So if you look at EUQS dot squared compared to the rectangle LRCT, let's first look at the angles. What do you notice about all of those angles? You should notice that they're all right angles. So all angles in those two quadrilaterals are congruent. But in order for these to be similar polygons, the sides have to be proportional. So 12 and 10 are corresponding sides, and 12 and 18 are corresponding sides. So is the ratio of ES to LR proportional to the ratio of SQ to RC? Well, if we set up a ratio for ES to LR, that would be 12 to 10, and that is not equivalent to the ratio of SQ to RC, which is 12 to 18. So this ratio is not equivalent to this ratio, so therefore sides are not proportional. And now let's look at the second one. So if you notice, side SQ correlates to side RH, and side ES correlates to side MR. So this ratio, 12 to 18, is equivalent to this ratio, 12 to 18. So we can say that the sides are proportional, but if you look at the angles, let's look at angle S, for example, and angle R. Those angles are not congruent. Therefore, those two quadrilaterals are not similar. All right, so now let's look at this last example. If we know that two quadrilaterals are similar, that means corresponding parts are going to be corresponding sides are going to be proportional, and corresponding angles are going to be congruent. So that means angle S and angle B are going to be congruent. It means that angle M and angle I are going to be congruent, and so on. So the first question asks you to find a side X. So we're looking for X, and we're looking for Y. Well, we know that angle M and angle I are congruent, and angle Y is the same as angle I. So Y equals 83 degrees. Now the second part is to find side X. And if these two polygons are proportional, that means that LS to EB, so we can write a ratio for that, 18 to 24, has to equal LA to EG, and EG is X. So it has to equal 21 by X. So now to solve this, we can cross multiply. So 18X equals 21 times 24, which is 504. And then to solve for X, we're going to divide both sides by 18. and we get x equals 28. So if you are trying to show that that polygons are similar, you have to show their sides are proportionate. If you know they're similar, then you know their sides are proportional, so you can solve for any missing pieces. So please jot down any questions or notes that you have, and we can answer them in class next time I see you. Thank you.